Hi dear students, welcome to Geeta's classes. In this class, we are going to see Laplace transform of some more functions like COSAT and SINAT. So till now we have seen the Laplace transform definition is L of f of t is equal to integral 0 to infinity e power minus st f of t dt, and L of k is equal to k by s, that is L of 1 is equal to 1 by s. If you substitute, k is equal to 1. And we have also seen in the previous classes, we have seen all these proofs. So L of e power at is 1 by s minus a, and L of e power minus at is 1 by s plus a, and L of sin h at is a by s squared minus a squared. L of cos h at is s by s squared minus a squared, and L of t is equal to 1 by s squared, and L of t power n is equal to n factorial by s power n plus 1. It can also be written as gamma of n plus 1 divided by s power n plus 1. So these are the formulas we have seen. All the proofs we have seen, even each and every proof is also important. So L of, next in this class we are going to see L of COSAT and L of SINAT. Laplace transform of the functions SINAT and COSAT. For that we should know this formula. So there are two different methods for finding the Laplace transform of SINAT and COSAT. So first method we'll see. We should know this formula. We know the formula integral a e power ax dx ax into sin bx dx is equal to e power ax by a squared plus b squared into a sin. Here remember, for sin you have to start with a sin bx, and for cos we have to start with cos, and for cos plus it is, for sin it is minus. Okay, so a sin bx minus b cos bx. We have to remember this formula. So now let us find out L of sin at is equal to, in this by definition we know that it is integral 0 to infinity e power minus st into sin at dt. Okay. So in this place of a, what do we have? Minus s. In the place of b we have a. Okay. So in the place of a we have minus s, and in the place of b we have a. So these are the values to be substituted. So this is equal to e power minus st divided by minus s the whole square. In the place of a we have minus s, plus in the place of b what do we have? A. So a squared into a sin bx. In the place of a what do we have? S. So minus s sin at minus, in the place of x we have the variable t. Okay, so minus s sin at minus, in the place of b we have a, then cos at. Okay, everything from 0 to infinity. And when we substitute minus infinity e power, it will become e power minus infinity. So for the upper limit it will become 0. Then for the second lower limit 0, e power 0 divided by minus s the whole square. So s squared plus a squared into minus s sin 0 minus a cos 0. So a sin 0, this will become 0. So this will get cancelled. So divided by minus and minus, it will become plus. So e power 0 is 1. So 1 by s squared plus a squared into minus of minus a, so it is a. So this is a divided by s squared plus a squared. Therefore L of sin at is equal to a by s squared plus a squared. This is the answer. Next let us see for cos. So integral e power ax cos bx dx is equal to, by formula, e power ax by a squared plus b squared into, I told you, if it is sin you start with sin, if it is cos start with cos, and for cos it is plus, for sin it is minus. Remember like that. Okay. So now let us see L of COSAT. is equal to, by definition, it is integral 0 to infinity e power minus st cos at dt. And here again in the place of a we have minuses, in the place of b we have a. Okay. So this is equal to e power minus st divided by minus s the whole square plus a square into e power, a cos. A is minus s. So minus s cos, in the place of b we have, yes, in the place of b we have a. So at, then plus b. B is what? A sin bt. Right? B is a here. A sin at. So this is equal to, and everything from 0 to infinity. After integration, the limits are from 0 to infinity. So when you apply the upper limit, again 0, it will become 0 for upper limit. And minus of, for lower limit, you will be getting e power 0 divided by s squared plus a squared into minus s cos 0 plus a sin 0. Okay. So sin 0 will become 0. This cos 0 is equal to 1. That is equal to, and minus will become, here cos 0 is equal to 1. So this will become, this entire term will become minus s. Okay. This will become minus s. So and minus will become plus. So plus s by s squared plus a squared. Therefore, L of cos at is equal to s by s squared plus a squared. Okay. So in method 2, so we have seen L of sin at as a by s squared plus a squared, L of cos at as s by s squared plus a squared. Now both together we can see another method. We know that L of e power iat is equal to, e power at is what? 1 by s minus a. So e power iat means 1 by s minus ia, and multiply and divide by s plus ia divided by s plus ia. Multiply and divide by s plus ia. So what will be there in the denominator? And the left hand side I can write it as L of e power iat can be written as cos at plus I sin at. Okay. This is equal to, in the numerator it is s plus ia divided by s minus ia plus s plus ia, that is a squared minus I squared a squared. So this will become s plus ia divided by s squared plus minus I squared is plus 1. Therefore s squared plus a squared. This will become plus 1. I squared is minus 1, minus will become plus. So in the left hand side I can write it as L of cos at plus I into L of sin at by linearity property. This is equal to s plus ia divided by s squared plus a squared. So by comparing the real and imaginary parts, or by equating the real and imaginary parts, on both sides, we get L of cos at is equal to, real part is here s by s squared plus a squared, and the imaginary part is L of sin at in the left hand side, and a by s squared plus a squared is the imaginary part in the right hand side. So both together we can find out. So whichever method you feel easier, you can apply that and find the Laplace transform of sin at and cos at. So L of sin at is a by s squared plus a squared, and L of cos at is s by s squared plus a squared. Okay. So with this, the Laplace transform of elementary functions are over, and we can do some problems, and you have to by heart all these functions so that it will be useful for applying in the problem. If you are thorough with these things, then only we can do the problems. Hope this will be useful. Please share it with your friends and give a like. Thank you so much for listening.